Enamines. Enamines are alpha-beta unsaturated amines and are prepared by the reaction between a carbonyl compound, which should contain at least one alpha hydrogen, with a secondary amine. As an example, now consider a compound having the structure R1, R2, CH, CO, R3. When it condenses with a secondary amine, the product formed is having the structure So it's a condensation product between a secondary amine and a carbonyl compound having at least one alpha hydrogen. And here R can be an alkyl, aryl, or even hydrogen. So if R is hydrogen, the compound will be CH3, CHO, that is acetaldehyde, plus a secondary amine. A molecule of water is eliminated and we get a compound CH2 double bond CHNR2. So this is an alpha beta unsaturated amine. So these are called enamines, or in general we can represent it like this. Enamines form from cyclic secondary amines like piperidine. Piperidine, it is the saturated analog of the heterocyclic compound pyridine, and pyrrolidine, it is the saturated analog of the heterocyclic compound pyrrole, are more stable than that obtained from acyclic secondary amines. For example, consider the compound pyrrolidine. When it condenses with a cyclic ketone, cyclohexanone, here also alpha hydrogens are present, and we get an enamine having this structure. that is alpha beta unsaturated amine. And here the mechanism is like this. The lone pair gets attached to the positively charged carbonyl carbon. Now nitrogen becomes positive. And this is the intermediate that gets changed to this dipolar structure is unstable, so that gets changed to that is an H plus is transferred to O minus and we get this intermediate structure. And one of the alpha hydrogen combines with OH minus and a molecule of water is eliminated and we get the enamine. Primary amines also form enamines and exhibit enamine-imine tautomerism, and since the equilibrium is shifted to the imine side, enamines cannot be separated. So if we consider the condensation between a primary amine and a carbonyl compound having alpha hydrogen, the resulting enamine will be having the structure C double bond C, then NHR. So this is the structure of the enamine formed from a primary amine with carbonyl compound, and this enamine, it tautomerizes and we get CHC double bond NR, and that is an imine. Imine is an unsaturated amine. And now let us see the resonating structures of enamines. So if you represent the general structure of an enamine, so the condensation product between a secondary amine and a carbonyl compound having alpha hydrogen, this enamine, it's a resonance hybrid of these two contributing structures. So the lone pair on nitrogen can be delocalized and we get a carbanion intermediate. is the alpha and this is beta carbon. And since the beta carbon carries negative charge, enamines can act as a nucleophilic center and electrophilic attack takes place at this site. Alkylation and acylation of enamines. In enamines, the beta carbon is negatively charged. You can see in the resonating structure. So it can act as a nucleophilic center. So enamines can undergo electrophilic additions like alkylation and acylation. For example, if you start with the enamine formed between pyrrolidine and cyclohexanone. When it is treated with methyl iodide. The beta carbon is negative, so the CH3 plus gets attached. So the methyl group gets attached at this position. And when this intermediate is subjected to hydrolysis, the product formed is an alkyl substituted ketone. So we get methyl 2-methyl cyclohexanone. So when cyclohexanone is converted to an enamine followed by alkylation, we can methylate cyclohexanone at the 2 position. Similarly, when this enamine is treated with an acyl chloride CH3COX halide, acylation takes place. And we get an intermediate like this, that is COCH3 group gets attached to the beta carbon, which is negative, and this on hydrolysis the product formed is an acylated cyclohexanone. So by selecting suitable secondary amines and ketones or aldehydes, we can prepare a large variety of alkylated and acylated compounds. So this is one of the important synthetic application of enamines.